if you have a square root in an equation. That's what 10.6 is about. We've been dealing, the whole chapter has been about square roots. Specifically, what do you do when you have a root and it's an equation? Notice we have a left side, right side. You know, it's not just roots added, subtracted, multiplied, divided. It's equal. An equation. So basically, we got to get rid of that root, don't we? How are we going to get rid of that root? How are we going to get that thing out of there? Charles? Yeah. Second power it, right? Remember that second power is the opposite of roots? Charles, I think you've had this class sometime. You seem to know all the answers all the time. All right. Yes, good. Good job. 2 power both sides. Exactly. You seen that before? That's the opposite of a root. That'll get rid of it. Now, you can just go like that, just cancel them out, and it's just 2x, and the other side is 10 squared. Oops. And what is 10 squared? It's 100, right? And then we just divide by 2. And so x is 50. And that's the answer. Now, hold on for a minute. I don't want to give you rules without reasons. I think you'll remember them better if you understand the reason. Why does a 2 power get rid of a root?
Because there's a 2 on the root.
Yes, let's go back and let's take this over on the side here. Like, why would root 2x squared, you don't need the parentheses, but I'll just, whatever. Why would that, what we're saying is they just cancel and just becomes normal 2x, huh? Why? Well, what does a 2 power on anything mean? Doesn't that mean there's 2 of them? So that's right? Yeah, and what's the rule for roots? What's in the hook there? What's in the hook?
2.
Yeah, nothing, so 2. And what's the rule when you got 2 or nothing? Same thing in the hook? 2 in? 2 2x's in? 1 2x out. That's why. That's the very basic rule of square roots, huh? If you got 2 in, you got 1 out. So that's how we get rid of the root. We just do a 2 power, then that's 2 of them in, ships 1 out, no more root. It's exactly how we get rid of the root. A root and a 2 power are opposites thereby, aren't they? Like an acid and a base or a poison in the antidote. They just neutralize each other. They're both gone. So that's what we're going to do. A 2 power and a root just always eliminate each other. That's the game plan for this section. All right, let's look at number 2. Square root of 4x is -9. Okay, so number 2, square root of 4x is -9. So try that one. Got to get rid of that root. So you want to do go ahead and use parentheses on both sides. It'll be helpful to make sure you do what's right that way. So parenthesis 2 power the left and parenthesis 2 power the right. That's these cancel, right? So this is 4x. What's the other side?
81.
Yeah, positive, huh? Because -9 times -9. Hey, why? That's correct. But what if somebody was to say to you, hey, why did you square the 9, 81, but you didn't square the 4 to make 16? Or the x to make x squared? Why did you square one side but not the other?
This is already done.
Why did I square the 9 but I didn't square the 4x?
But the root
Well,
and the
you already
square
did
cancels
those.
each
The
other out.
root canceled it.
Yes.
The square could not have his way to square the 4 making 16 because the root took it out. Whereas on the right side, there was no root to take out the square, so the 9 was squared. 9 times 9, 81. Right? Everybody seeing the difference? It's going to happen on all. I want to make sure you're really getting why. On one side, we just cancel it out because a root and a 2 power are opposites. So they cancel out. You don't actually get to 2 power the thing inside. It's protected, so to speak, by the root. And they cancel out. But on the other side, you do. Right? And then now that the root is gone, it's easy to solve. What do we do to finish solving? Yeah, no, just divide by the 4. And so we get x is...
20 1/4.
Yeah, I think you just want the fraction. Just leave it that way, 81 fourths.
81 fourths?
Now, there's a thing I need to tell you, though. That's not the right answer. Having done all that, not a bummer. Here's why. I mean, all that's correct work, but this problem has no solution, actually. That's actually a faulty solution. You have to check this method because it can bring in falsity. Let's go up and see. Let's check our answer. I didn't check the last one, did I? Let's check the last one. Let's just go back real quick. Am I confusing you by here? Let's do one at a time. I'm probably confusing. Let's check this one. Now, how do you check the answer? Let's see if it really is the answer.
You plug
Yeah.
in an X.
And for the x, so start with the original question here, which was square root of 4x is negative 9. And you take the answer, 81 fourths, and you put it in for x right there, huh? And so what are we going to get? Square root of 4 times 81 fourths is negative 9. Is that true? Well, the 4's cancel, right? Because this is 4 over 1. Cross cancel. So what are we left with? Square root of 81. And what is the square root of 81? What times itself is 81? 9. Positive 9, huh? Not negative. Does that equal negative 9? No. So this is crossed off. No solution. There's actually no solution to that question. You have to check these. The method is not reliable. It's the best thing we've got, but it's not foolproof. It can give you false answers. It's like having a friend that lies sometimes. I don't know if you have any friends like that. You don't want to really make them your really close friends because you always got to be checking for when the lie comes out, right? You never know when that's going to happen. Does that make sense there? Let's check the other one. So I really should have checked the other one. If we went back to number 1 and we checked it, and we had the square root of 2x is 10. If we took that 50 and put it in, you see it would have worked fine. We would have got the square root of 2 times 50. And what's 2 times 50? 100. What's square root of 100? 10 equals 10. So it worked. That's why that was a valid answer. That's what an answer is supposed to do, right? Make it true, make the left side and the right side equal. And that one did work perfectly, right? It made 10 equal 10 here. So 50 was really the answer to number 1, and number 2 has no solution.
Is there anything that we need to be looking out for in that case, no solution?
Or what we see that equal to -9 because
Yeah, I mean, that is, you're right. It basically, a square root can, if you know a little bit more, I don't want to give you too much, but
I cannot give you negative.
yeah, square root can never be negative. We really could have known right from the beginning. Now, they're going to be more tricky than that in the future. But yeah, square root can never equal negative. There's nothing that could have ever made that true. All right. Plan for solving, so when you have a square root with an equal sign, step 1, get the root alone. Step 2, parenthesis 2 power, parenthesis 2 power. Step 3, check your answer. So there's the 3 steps you want to follow. This is for the whole section we're doing today. Anytime you have a square root with an equal sign. Those are the 3 steps you want to follow. Get the root alone, parenthesis 2 power both sides, check your answer. So follow that like a recipe. So what am I going to do then on step number 1 on this problem? I want to get the root alone, right? Here's the root right here. I want to get that alone. So what will get that alone?
You put it in parentheses, inside the parentheses.
So here's the equal sign, right? And that's the left side, right side. And what it means is this square root is saying, I want to be all there is on my side. That's what it means by alone. So what do we have to get rid of? That -2 first, huh? Yeah. So add the 2 to both sides. Boom.
Does that make sense? So get the root alone, step number 1. Here, I'll just put it right here. So we added 2 to both sides to get the root alone. Does that make sense? So the root's all there is on the left side now. What's the second step? I'll let you take it from there. I think you can do it from there. What's the answer on this thing?
X equal 8.
Yeah, I think it's 8, isn't it? So we parenthesis 2 power, so that's the second step. Parenthesis 2 power both sides. A root cancels a square. And we get 2x minus 7 is 9. We good there? And now add 7 to both sides. So once you get the root out of there, just solve it like normal. You know, the whole thing is let's get that root out of there, and then it's just normal. So what do we get then? We get 2x is 16. Last step, divide by 2. So x is 8. Maybe. We have to check, huh? So now let's go up here and check. I'm going to erase this stuff. It's on the board for you. So let's go check. So we take the original question. Square root of 2x minus 7 minus 2 equals 1. Grab that 8 and put it in. So what do we get then? We get square root of 2 times 8 minus 7 minus 2 equals 1. To make sense, whatever we check on the very first step. Go back to the very first step and we put in the 8. And then we work it out. So what is that? 16 minus 7, 9. What's the square root of 9? 3 minus 2, 1 equals 1. Works perfect, huh? See how that answer 8 made the equation true? So that's the real answer. So it usually does work. I mean, it's more rare when it doesn't. So 8's the true answer. Made the equation true, right? Yeah.
I did it a little different, but I still got it like equal.
Yeah, did you like add the 2 over or something? Yeah, that's totally fine. Doesn't matter how you do it as long as you get them equal in the end.
Okay.
Yeah, that's good. Well, actually, let me say one thing. The only thing you don't want to do is in the check, you don't want to 2 power both sides. Because that's actually the questionable step. Yeah, you might wonder, I mean, I would be fine. I'd be like, why do we have to check this also? Why can he give us wrong answers? It's because of the fact that 2 powering both sides can take something false and make it look true. Let me show you. What if you had like a 3 equals negative 3? Now, that's not true, is it? 3 does not equal negative 3. But, whoops, if you take both sides and you 2 power both sides, it'll become 9 equals 9. See how 2 powering can take something false and make it look true? That's called lying, right? When you take something false and make it look true. Right? So, and we have to do it because that's how we solve to get rid of the root. But that can bring in falseness, can't it? It can also give us the right answer. It just sort of depends. And and they can be more subtle, you'll see, in the way they hide it. It's not always so obvious. That's like pretty obvious. There'll be more. Here we go, number 4. So what do we do? Now that one's a cube root instead of a square root, right? It has a 3 in the hook there. So see what you can figure out. Go use those steps. There's just one. What do you think we're going to do different on step 2? Instead of 2 power both sides, what are we going to do?
3 power.
We're going to 3 power both sides, right? What's the first step? Yeah, add the 2 because we got to get the root alone, huh? So step number 1, get the root alone, add the 2 to both sides. Step 1, get the root alone. So step 2, you're going to third power both sides. So third power both sides, because that gets rid of the root, doesn't it? So a third power gets rid of a third root, 2 power gets rid of a 2 root, etc. So those cancel. What's the other side? What's 2 to the third power?
8.
Yeah, 2 times 2 is 4 times 2 is 8, huh? And now once the root is out of there, it's pretty easy to solve. How do you solve it?
You add the 8 to the other side.
Add the 8, that's right. So the x is 16. Now, there's a special reason why we actually don't need to check it. I'm not going to do step 3. I refuse to do step 3. We don't need to. Why? Why would you not need to check a third root, but you do need to check a 2 root? A 2 root can lie to you, but a third root will never lie to you. Why not? Remember how a 2 root lies to us? Let's go back and look at this.
So
See,
minus to minus give you positive.
yeah, it turns that negative to positive, right?
But odd numbers don't.
Yeah, odd numbers, exactly, Manuel. Yeah, so let's what if we took this same original thing, 3 equals negative 3, that's not true, and we tried third powering both sides. If I third powered both sides, could that cover up the truth? No, because this would be positive 27, and this would still be negative, because 3 negatives stays negative. See how it doesn't cover up signs? It doesn't bury negatives? So it'll never lie to us. So you only have to check the 2 root. You don't have to check the 3 root. So we're done. I mean, you can check it if you want to, but it's always going to work. 16 is the true answer. Third roots will never lie to us because they don't bury negatives. Whereas 2 powers, 2 negatives becomes positive, huh? It buries negatives and thus could lie to us about the right answer. But a third power will never do it. So is that good? So third powers are easier. Is all well? Okay. All right, so this is going to be harder because we have an extra x in there. This is where things get a little more messy. So let's stick with our recipe, though. What's our first step? When we see a root with an equal sign, right? I see a root with an equal sign. What is step number 1?
Get the root alone.
Yeah, step 1, get the root alone. So what do I do to get the root alone? Yeah, get rid of that x, huh?
Yeah.
Because the thing with the root is the negative x, or the regular x. So subtract x from both sides, gonzo. So negative root 3 minus 2x is negative 6 minus x. We okay so far? You know, it'd actually be nice to get rid of all those negative signs. I don't know, we don't normally do this, but since everything's negative,
Multiply by minus 1.
yeah, just multiply through both sides by negative 1. So let's do that. So multiply by negative 1, negative 1, negative 1. And that'll become positive root 3 minus 2x, positive x plus 6.
Would it be the same if, I know it's like a lot, but would it be the same if you added, like could you?
Yeah,
add the-
no, that's a good thought. Move this to the right side from the beginning,
Yeah, and then flip
and
it.
then move this back. No, beautiful, good thinking. That's exactly the same thing, huh?
Okay.
That'd be the same result. The root would just be on the right side instead of left. Yeah, that's another good idea. Just move it like that, and then we'd be same place we're at now. So there's step 1. Get the root alone. The root is alone. What's step 2?
Multiply by the power.
Yeah, so 2 power. Step 2, you do now this is where you really need those parentheses. Don't skip that. Parenthesis 2 power, parenthesis 2 power, both sides. So parenthesis 2 power, parenthesis 2 power, both sides. Good there? Now, remember how this works. there's an easy side where the root just cancels the square and nothing else happens. Which side's that? Left side or right side?
The left side.
Yeah, right here, these guys just cancel. No big deal at all. It's just 3 minus 2x. But on the other side, is there a root to cancel out the square? No. So on that side, the 2 power is going to have his way, and we're going to have to write 2 of them, huh? Remember when 2's on a parenthesis, you got to write 2 of them?
Oh, okay.
And you have to FOIL that whole thing out. You tracking with me?
Okay, that's nice. Oh, I was thinking about like develop 6 times 6, 36 plus x squared.
So on the right side, we FOIL it out. We're going to FOIL the whole thing out. First to both, second to both. So 36 plus 6x, boom, boom, plus 6x plus x squared. Right?
And we reordered it? Or?
Yeah, then now, good idea. Let's gather some like terms. So 6x and 6x, 12x. What now? This is kind of weird. I mean, where are we going? It feels like we're just on this wild trip, kind of going nowhere. But actually, we are getting somewhere. But it might seem that way. What should we do now?
Factor.
First, so when you see this right here, something needs to jump. You need to know this so well. When the next month, we'll use this so often. You really need to know it. Just somebody wakes you up in the middle of the night and says x squared with an equal sign. You need to go get a 0. Get a 0.
Or the both sides? The 0 or the...
Yeah, so let me write that game plan out. So it's like we're shifting gears now into another game plan. When you have x squared with an equal sign, step 1, you've got to get a 0. Step 2, you've got to factor. Remember that, where we do the parentheses? And step 3, each part gets its own 0 and solves. Remember that? So let me bring it back. Was it 3 minus 2x? Okay. 3 minus 2x equals 36 plus 12x. Okay, so here's the equal sign. Yeah, so this is a whole nother process we've suddenly jumped into because x squared showed up. So you want to know that whenever x squared shows up. So what's the game plan? Step 1, get a 0. Where do I get a 0? On the opposite side from x squared. So where's x squared? X squared's on the right side. So where am I going to get a 0? On the left side. I'm going to make the left side become 0. So go over there to the left side and make it 0. So how do you make it 0? Do the opposite of both those, huh? Because that'll make that side 0. So I just did opposite, opposite. Now that side will be 0. And whatever you do to one side, no choice but do the same thing to the other side. Gonzo, gonzo, right? So we have 0 equals, this is what, 33 plus 14x plus x squared. We should reorder that. That's really not in the right order, is it? What's up and bugging you? Christina, yeah. All right, so there we are. We reordered it. Everybody tracking with me? Now what? So step 1, get a 0. Step 2, factor. How do you factor that? 2 parentheses, x is in the front. What are 2 numbers that multiply to be 33, add to be 14?
11 times 3.
11 times 3, both positive. They'll add to be 14 in the middle, multiply to be 33. All right. And then, step 3, each part, remember, because if 2 things times to be 0, If I said, hey, I'm thinking of two things,
put
they
the two
times to be
zero
0.
now.
Either one could be 0, right? If you're multiplying two things to be 0, either one, if the first one is 0, 0 times anything can be 0. Or if the second one is 0, anything times 0 would be 0, right? So that means the first one could be 0, or the second one could be 0. Jump it over, negative 11, negative 3. Maybe. But remember, this problem began with a square root. So what's our we're still, it turned into x squared about halfway through, but it's still under the heading of square root problem. That's how it began. So any problem beginning with a square root, what's our final step 3?
Check.
Check the answers. So both, usually one of those is bad and one of those is good. Not always, but usually. So we have to check each of them. So I can go on a whole separate screen here. We're going to check both. Is that okay? Is it okay if I flash off that? We have to check both those. So I'm going to check x equals negative 11, that first one. And then check x equals negative 2, that's the other one. Yeah. So let's check them. Now, where do you check them? Into the first step. It's always the first step. So, what is it? X minus root of 3 minus 2x. The original question is negative 6, right? Yeah. So, yeah, I'm going to check each of these separately. These get kind of long, don't they, with all the checking and all this stuff? So let's plug it in. So I'm going to take that negative 11, and I'm going to put it in. And let's work it out. So we get negative 11 minus the square root of 3 minus 2 times negative 11 is negative 6. And that's negative 11. Then you just work out the numbers. You can use calculator, whatever you want. You're just working out the numbers to see if the left side equals the right side. So this is 3 plus 22. 25. What's square root of 25? 5. Negative 11 minus 5, that's negative 16. Does that equal negative 6? No. So that answer is no stinking good. It's out. It didn't make the left and the right equal on that. Let's check the other side. So on the other side, we're going to take that negative 3 and we're going to plug it in. And x can only be one number at a time, huh? Either it's negative 3 in both spots or it's negative 11 in both spots. You know, whatever works. We'll see. So, negative 3 minus 2 times negative 3. 3 plus 6. Square root of 9. Square root of 9 is 3. Am I going too fast? So I'm just working out the numbers. I'm not doing any fancy, operations. I'm just simply adding, subtracting, square rooting, just working out the numbers. Negative 3. If you lose $3 and lose $3, you lost $6. That would work, huh? It made them equal. Now, careful. The answer is not the negative 6. It doesn't really matter what these numbers are. You're just making sure they're truly equal. That just verifies that x equals negative 3 really does bring balance to the equation. Right? So the real answer, the only answer, is x equals negative 3. Good there? So that's the only answer. The other answer was no good. So x equals negative 3. It made the equation work, didn't it? It made the left side equal the right side. That's what an answer is supposed to do. That's what a solution is supposed to do. Make it true. Make left side equal right side.
Can you go back to the screen for me, please?
Everybody good with this screen? Just making sense?
One more. Thank you.
So that was a long problem. Questions I can answer on it? Yeah.
I did that thing again, where I moved the 11 to the 6.
Right.
Could I still do that, or is it just?
Eric, are you good with that screen?
Yes, thank you.
All right. So, you mean you added the 11 to the other side?
Yeah,
Oh, you mean on the left side?
from the left side,
Yeah, and so you got negative 5 equals
and 5,
5,
yeah.
which is not true.
No.
Yeah, no, it's totally
But
fine.
it's okay.
Totally okay. Yep. All right. Okay, yeah, this is going to be a bad one. So it's a double rooter. It's got 2 roots in it. It's going to be like 4 or 5 screens. So what do we always do? What's the first step when you got a root? Get the root alone. And see how they're together? We don't want them that way. That'll mess us up. So basically you want to move one of them over. Like, let's just take that guy and move him over. So here's the equal sign, right? So this one will come down. Square root of x plus 11 is 7 minus the square root of x minus 24. Why am I doing that? Because remember our 3 steps. Remember the recipe I wrote on the board. Step 1, get root alone. So on the left side, I got the root alone. He's all there is on that left side, huh? Now, you might say, yeah, but the right side, the root's not alone. You're right. It's going to be a big problem. But that's the best we can do. We only have 2 sides. We have 3 items. Not everybody's going to be alone. There's no way to get it. But at least one of the roots is alone now. That's an improvement. Okay. Now, watch this. This is what I see many times on exams. Probably it'll be done by those people that are not here today. But hopefully no one will do it. But I usually see this. I'll go square, square, square. Don't write that down. That's crazy. But it works so well. Watch this. It just cancels out right there. Here it's 7 squared is 49. Cancels right there. Right? Like that. You got to remember those parentheses. Distribute that. Don't write any of this down. It's all garbage. Plus 24. And they go, all right, this is working great. Add x to both sides. 2x plus 11. 49 and 24 is something 60, 73. Subtract the 11. 2x is 62. Divide by the 2. X is 31. Why is that all garbage? What did I do this wrong? Didn't I squared both sides? No, I didn't. That's wrong. What do you mean? Isn't that squaring both sides?
Because 7 minus square root.
It's like 3 terms.
Yeah, what does my step 2 say? Parentheses square. Parentheses square. That's different. That matters. I want to make sure everybody sees that. It'd be great if we could do this. This would be way easier. We'd be done in 1 screen. No, it's going to be a 4 or 5 screen question. It's way longer than I'm sure they would look at the test and go, why am I trying to leave all that space? That was an easy one. I don't know. No, you can't. No, that's totally wrong. That answer is garbage. It isn't the truth at all. It's fairy tale mathematics. So instead, what's wrong with that is we're going to square. That's true, but not like that. You have to you have to go square with parentheses the whole left and square with parentheses the whole right. Why? That's all that's true.
Because there's some minus.
That other thing would be really convenient, but it just isn't true. So, I could let me prove it to you real quick. I don't want you just to. Well, think about 1 plus 2 equals 3. 1 plus 2 equals 3. That's a true statement, isn't it? If I take that, don't write this down, but watch this. If I take that and I go square, 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 is it still true?
Nope.
What is it now? 1 plus 4 equals 9. Do you see how it's not true to pass out squaring? Squaring is not like multiplying. You can't distribute it to everybody. Right there, that just proves it just ain't so, is it? It's just not true if you have 2 separate things and one other thing that you just go, and they're equal, you go square, 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 and they'll still be equal. They will not still be equal. That's not true. It's not like multiplying. I know that's why people get it confused. They think, well, you just go times, it's squaring. If it's squaring, you can't do that. All that's true, what is to put 1 square and 1 square. That'd be true. 3 squared, 3 squared. That's true. But not individual for each one. It's just not true. All right, so we can't. That's why I'm specifically writing the parentheses on step 2, because that's all that's true. Okay, so what happens? Let's get back to what's true now. The left side, these cancel. I'm going to move it way over here. So remember, we always have an easy side and a hard side, right? The easy side is where the root and the 2 power just cancel each other out. Now, on the other side, you can't just take that 2 and go square, square. That'd be equivalent to the other bad thing I was doing. You have to write 2 of those whole parentheses. That's where it's going to get awful. So you got to write 2. Whenever a 2 power is on a parenthesis, you have to write 2 of the whole parentheses, like that. It's going to get terrible. All right, so now on the right side comes a pretty challenging FOIL. Remember the rule now. Outsiders with outsiders, insiders with insiders. Right, here we go. That 7 is going to go to both. Yeah, I can take turns. First to both, second both. 7 times 7, 49, minus 7. And then that 7 will just stay outside the root, right? He's an outsider. He doesn't go in. He's done first to both, and now second to both. Minus 7 root x minus 24. And then negative root times negative root is positive x minus 24. Did you see what happened there? 2 roots made 1 out, and 2 negatives made it positive. Let me say that again. Remember, root times a root?
Get 1 out.
1 out. Remember, if you have 2 of this, just like root 11, 1 plain 11, isn't it? Remember, if you have 2 of the same thing in a root, that's 1 plane out. Like if I had root 11 times root 11, that would, because that's 2 11s in, that would send 1 out. Well, that's what just happened there in that last step. An x minus 24 in, another x minus 24 in, and 1 x minus 24 out. And a negative times negative made positive. Good there? We tracking? Okay. Let's gather like terms. So x plus 11. The other side, 49. Minus 7 roots, minus 7 more roots. You guys had the section on like terms. Remember you just added?
14?
Minus 14 of the root x minus 24s. Plus x. Oh, I should have combined 49 and minus 24. They're just plain old numbers, right? They can just subtract. What is that? 25? So everybody see what happened there? I just took that plain 49 and subtracted the minus 24 way at the back. They're just like terms, there's numbers, right? They just subtract, good? Oh, maybe good's a strong word, but okay. Okay so far? Now look at this mess we've got. Doesn't feel like it's getting much better. What should we even, it's easy to just do the deer in the headlights at this point, just freeze up. Like, what am I going to do? This is just a mess. One thought should drive you forward. We have a root still on the scene. He's right here. He's saying, I'm a root. When you got a root, you know the recipe. Get me alone. That's where we're moving. Did we just do that? Yeah, we did it once.
Do it again.
This is a double rooter. This is a long one. We got rid of one of them, but now we got to do another one. Yeah. So whenever you got a root on the scene, even halfway through the problem,
Move everything to the other side.
get it alone. Yeah, move everything to the other side. Get that root alone.
Minus x.
Yeah, I'm going to leave that 14 right on him. Yeah, I'll show you. Good question. Exactly. I'm going to leave it. It's not it's kind of connected. But I'm going to leave it. I'll give you the reason why. Root x minus 24. All right, so let's get that root alone. So let's subtract 25, and let's subtract x from both sides. Good. Gonzo, what's that? Minus 14 equals minus 4. Oh, actually, so yeah. It good so far? How are we doing? Are we happy? So I'm moving towards isolating that root. So I got rid of the 25 and the x. Now, can I get rid of that? So I changed my mind. I didn't know it was going to be this clean. I'm going to get rid of it.
So how can I get rid of that minus 14?
Minus 14 was doing, he's adding or he's multiplying?
Yeah, you tell me what's in the middle, right? What's right here in the middle? Nothing. So it's timesing, isn't it? Remember, the middle tells us how they relate. Their relationship
So you
is determined by what's between
14
them.
by 14.
So I need to divide, don't I? Because they're multiplied right now. So I need to get rid of him by dividing, right? Does that make sense? So I'm going to divide both sides by minus 14. So this is positive 1. Actually, this is working out fairly nice. I think we'll be done in 3 screens. We good to there?
And then we go parentheses again?
Yep. We got the root alone. Do it again. Yeah.
Why is it multiplying again?
Because there's nothing in the middle.
Okay, but if there's a plus, then you couldn't get rid of it?
If there's a plus, then I would add the 14 to both sides.
Oh, okay, got it.
Does that make sense? Yeah.
So it's not like a package?
No, it's not glued. Pluses and minuses in the middle glue things.
Okay.
Yeah, it's not.
25
So now we gotta,
Does that make sense? I want to pause and make sure everybody's good with that. So you always look, that's one of the things I notice when people are just learning algebra is they don't look enough to the middle. They'll see the things, the minus 14, but they won't think about the relationship.
When you do
So
parentheses,
that's a good question.
1
In the
one,
middle is
and
nothing,
next
which means time.
minus 24 is
So we divide.
just get rid
no,
of
because
the
we saw some stuff.
Okay, next step. So what do we do when we have a root?
parentheses again.
Yes.
Parenthesis 2 power,
Yep.
parenthesis 2 power.
You'll never
And they just cancel each other, so it's 1.
Root cancel squared. And what's 1 squared? 1 times 1? Just 1. The other side, the root vanishes because the 2 power cancels it.
25.
Last step to get x alone. Add it over. Boom. 25. Well, I'm kind of running out of room there. X is 25. Maybe.
We need to check it.
We got to check it. It could be a false answer.
Oh my God, can you just check it?
When did the x minus 24 get into the square root? I don't know, off somewhere.
It's been there from like the beginning. From the very
I
beginning.
wrote the problem wrong, that's why. Okay, I was like, I was getting adding 24 times.
Gotcha. All right, so we have to check it. We good? Let's check it. Everybody got that all copied down, and we'll go to the check. But maybe I can just squeeze it in right here. We might make it in 2 screens.
25 plus 11.
Check. X is 24. Check it with the original. Root x plus 11
So it's 36
plus root x minus 24
plus 1.
equals 7.
Yeah, it is.
So let's check it out.
1.
Grab that 24, put it in. Put it in. 24 plus 11. It's kind of nice when it works out, isn't it? So putting in the 24. Did I do that right? Yeah. Oh, the answer is 25, not 24. Yeah.
Yeah.
Thanks, I'm being crazy. Sorry.
So they make it,
What are you guys doing?
make it
It's
real.
not right.
Is it not right?
It's right.
No, it's 25.
25?
Yeah, but it's putting 24.
I messed up, Manuel.
Because he forgot to add the 1.
That's right. I did.
Sorry.
No, it's good. It's all true. All right, does it work?
No.
Yeah.
6 plus 1 equals 7.
Oh.
We all good?
Square
root of 36 is 6, square root of 1 is 1. It
I
works.
get 1, you know, like after all.
25 is the real answer. So that's the real answer.
Good job on that.
All right, how we doing? We got 20 minutes. I want to do as many as I can. We good on that one?
Oh my God.
Double rooter. So that's probably the hardest one right there. Probably. I can't. Number 7. So what's the game plan when we see a root?
Get it alone.
Get it alone and 2 power with parentheses, both sides. Yeah, it might be nice. Why don't we just move that thing? We don't like that root being negative, right? How about this? Would this be easiest for y'all? I think maybe it would be. Just jump that guy to that side. And then just jump this guy back to that side. So we'd have plus 9, plus 1, and plus root 5x that way. Everything's kind of, get rid of all those negative signs, everything's positive. keep going. That's like things positive. We don't mess with negative signs that way.
This is the one we started on today.
So we got the root alone. Now what do we do?
We resolved that for A.
I'm like, no.
So step 1, root alone. Step 2, parenthesis 2 power, parenthesis 2 power, huh?
You're right.
10 squared is 100. The other side, rooting cancels squaring, 5x. Is that good? So remember, you always have the easy side where the root just cancels out the square, right? And the hard side where you square. Not good. Next step, get x alone. Divide by 5. So x is 20? Maybe. We have to check. Let's go see. So check. X is 20. So we always grab the first original equation before anything was done. And just plug in the answer and work out the left side, work out the right side, see if they're equal. Pop in the 20 there. So minus square root of 5 times 20. So you don't have to, on the check, you don't have to do anything fancy. Just, you don't have to move things around or 2 power, and just work out the numbers. Just work out the numbers on your calculator. That's 100, right? 5 times 20, just use your calculator. That's all it is. Square root of 100, that's just 10. Negative 10 plus 1, it worked.
Yeah.
That's all it is. So that's a keeper. So the answer is truly 20. We good with that? Questions I can answer? In the hang of these?
That's right.
All right, I'm going to keep moving. See number 8, 4th root, 4x plus 1 minus 2. Fourth root, 4x plus 1 minus 2. Yeah, all right, try that one. So got a 4 in the hook there. So you know what you're going to do. Get that root alone. And then your 4th power both sides, right? Add 2 to both sides.
Oh, yeah, I did.
So how do you get rid of that 4th power? 4th root? You 4th power. Parenthesis 4, parenthesis 4. And these cancel. There's always the easy side where they just cancel. And nothing happens. The other side, you got to work it out. So that other side is going to be 2 times 2 times 2 times 2. What's that, 16?
Not true.
So then we finish it up. So subtract 1 from both sides. 4x is 15. Last step to get x alone. Divide by 4. 15 fourths. Maybe. Let's check it. We got to check it. Let's bring it up here. So I'm going to check x equals 15 fourths. Where do we check it? The first step, original question. 4th root of 4x plus 1 minus 2 equals 0. So I'm going to grab that 15 fourths and put it in right there. See if it works out. Okay. So we have the 4th root of 4 times. And make sure you see how far the root goes. You know what I mean? the root stops over the 1. Right? The root goes over the 1, but it's not over the -2. Right from the beginning. So be careful with that. I see people make a lot of mistakes with that. So working that out, what are we going to do? These cancel, don't they?
Yeah.
So that's the 4th root of
15
15 plus
plus 1.
1. Okay, and so then that's the 4th root of 16. Now, what's the 4th root of 16? Yeah, what times itself 4 times is 16? 2. Yeah, if you broke that down, that'd be 4 times 4, 2, 2, 2, 2. 4 2's in, 1 2 out. Minus 2 is 0. Yeah, it worked. The answer is truly 15/4. That last step makes sense how I did that 4th root, right? Just break down the 16, right? 4 in the hook is a 4 shipper, huh? 4 2's in, 1 2 out. Minus the other 2. So this 2 dropped to here, and this one became 2. 2 minus 2 is 0. Yeah, 0 equals 0. It's true. 15/4. Questions on that one? All right. So what should we do on this thing?
Multiply -1 to the right side.
Just parentheses.
So we got roots. Stick with the recipe.
I know.
Get the root alone.
They're
They already are alone.
Are
So
there two
we just
other
go,
rows?
step
So
number
go right
2.
to the 2 power step, huh?
Yeah.
Yeah. So go straight to the 2 power step. Because they're already alone. You know what I mean? There's nothing outside of them with them. So go right. So go 2 power the left side, 2 power the right side. That good? Go to the 2 power step.
And then we just get rid of it.
And basically it just gets rid of both roots, doesn't it?
Minus 1 equals
And then just go from there. Solve it from there. And remember to check your answer.
Just drop it to the other side. 6x equals 2. X equals 2 sixths. X equals 1/3. And then check the answer.
So what do you do when you got x's on opposite sides? Yeah, get rid of one. Do the opposite of one of them, huh? Boom, like that. So that'll be 6x minus 1 is 1. And then add 1. Boom. So 6x is 2. Last step to get x alone. Divide by 6. So x is 1/3.
Yes, 1/3.
2 6. I just reduced it to be 1/3. So x is 1/3, maybe. Got to check. So let's take the original question. Square root of 3x minus 1 equals the square root of 1 minus 3x. Let's put in the 1/3. There. And there. And so what do we get? Square root of 3 times 1/3 minus 1. Square root of 1 minus 3 times 1/3.
0.
And 3, what do you do with 3 times 1/3?
You cancel and you get 1.
1 minus 1. And then same thing here. Square root of 0 is square root of 0. 0 equals 0. Yeah, made it true. Again, 0 is not the answer. That just proves that 1/3 is an answer. We don't really care what these two numbers are at the end, 0 or 10 million. If they're equal, that means the 1/3 is a real answer. It made the left side and the right side equal. That's all we care about with the check, is that the left side and the right side are the same number. We don't care what that number is. It just means 1/3 brought balance to the equation, made it true. That was the one number that could make it true. So we haven't had many no solutions for a while. Good there on that? So that's, those other ones I skipped are just a question. Wants me to find that unknown side, call it x. How do you find the bottom of that triangle? Have you seen do you know of a formula? I can't remember if we've done it or not. Where you have like a right triangle.
Times
Yeah, a squared plus b squared equals c squared. Have you seen that before? For any right triangle, a squared plus b squared is c squared. What's that called?
Pythagoras,
The Pythagorean Theorem. Yeah, Pythagorean Theorem for any right triangle. So anytime they give you a right triangle, you can do the Pythagorean Theorem. So now, when you use the Pythagorean Theorem, a squared plus b squared is c squared, the a and the b are interchangeable, doesn't really matter at all. You just got to make sure you get the c, the right one for the c. And the c is always the longest side. And we also call it the hypotenuse. Have you heard of that before? The hypotenuse. So which one, looking up at the original triangle, which one's the longest side? Which one's the hypotenuse?
8.
Yeah, the 8 is the hypotenuse. It's the side across from the right angle. See how the other two, the 4 and the x, touch the right angle? But the 8 is the longest side across from the right angle, called the hypotenuse. Yeah, so just make sure that one is the c, because the other two add up to be it squared. So it's got to be the biggest. The other two, the order doesn't matter. 4 squared, x squared, or vice versa, whatever. So what's 4 squared? 16. 8 squared, 64. How do we solve for x here? And get the x squared alone, huh?
64.
Subtract 16. 8 times 8, 64. So subtract 16. Bring it up here. We have x squared equals 64 minus 16. I don't know. 48?
48.
Yeah, 48. Okay. What do we do now to finish solving for x there?
The rule gets around.
Root 48.
Well, yeah, that's only if you have a good question. Yeah, I should have written on the board, if you have x squared and regular x, that you have to do the get a zero factor thing. If you just have x squared and a number, just root it. And all we got to do is root it. So root, but, yeah, well, let's just root. So square root of 48. Now, I don't know what they want me to simplify that square root of 48. Remember how to simplify roots? You guys are pros at this now, right? Break it down. 6 times 8, 2 times 3, 2 times 4, 2 times 2. So x is the square root of 2. How many? 4 2's and a 3. 4 2's and a 3. What happens? What's in the hook?
2. So
2. So 2 for 1 deal at target. 2 2's in, 1 2 out, 2 2's in, 1 2 out. 2 times 2 is 4. Square root of 3. 4 square root of 3. That's x. We don't need to check it because the problem did not begin with a square root, did it? It ended with a square root, but that's different. The problem did not start. It's only problems that start with a square root that you have to check. Is that making sense on that? So hold on. We still have 4 good minutes, my clock says. I want right triangles. So just know as you begin to read these words, it's a right triangle. Here we go. Spotlight is mounted on the eaves of a house 24 feet above the ground. So spotlight's high above the ground.
24.
A flower bed runs between the house and the sidewalk, so the closest the ladder can be placed to the house is 10 feet. How long a ladder is needed so that an electrician can reach the place where the light is mounted? Okay, so in other words, I know it sounds kind of confusing, but basically you have a house with a straight side, and up here at 24 feet high is some light that the electrician is going to work on. And he's going to, and here's the ground, and he's going to put a ladder down that is 10 feet
Away from the wall.
away from the wall. Does that make sense? This is the ladder.
So there we got that feet.
This is the right angle. Yeah, and so we want to find out how long the ladder needs to be. That's all they're saying. So the ladder, yeah, the ladder's the C, huh? So it's a right triangle. And so our formula is?
A
A squared plus B squared is C squared.
24 square.
Let's do that. And so that's going to be 10 squared. Now, which one's C? Oh, we already said it. The latter, huh?
576 plus 100.
100 plus 576. It's 676.
676.
Is that rootable? Does that come out nice? Then you square root both sides, right? To get C. Nobody knows? Is that rootable? Oh, yeah, it's just 26, right?
26.
Boom. That was nice.
Boom.
Is that good to there? We'll set up one more for you and then we'll be out of here. Let me just make sure you know how to do number 7 and we're going. So is that good there? So I'm just reading the words, looking for a right triangle. C is the length of the ladder, 26 feet. All right, look at number 7. Formula V equals 2 squared root GH gives the velocity in feet per second of an object after it falls h feet accelerated by gravity. There's a little physics here. If G is possibly the... Okay, so on these ones, and it's probably going to be the same thing, on 18, same thing. Now, yeah, these are super easy. They look fancy, but they're just plug-ins. So let me show you that, and we'll be done. Save you hours of your life here. These are not hard. Just grab the formula. There it is. V equals the square root of 2GH. You don't even need to read all their words. Blah, 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 whatever. They say G is 32. So put 32 in for G. And what else do they give me? 128. And what is that?
That's a V.
Velocity. That's V. That goes right there. So 128 goes here. 2 times 32 times h goes there. Does that make sense what I did? So you don't even need to read all their words. Just grab the formula. And they're telling me G is 32, V is 128. Pop me, and find the remaining letter. So what's that going to be? 128 is the square root of 64h. Now, how am I going to solve for h there? How do you get rid of that root? 2 power it. Not square root. Root, that is a root. Square it. 2 power it, right? So 2 power, both sides. Root cancels square. Right? There's always an easy side where the root just takes out square. What's 128 squared? It's a big number, huh? I knew it. All right. 16,384, thank you, is, and the other side just tears off the root. 64h. Last step to get h alone. Now the root's gone, right? They're just testing that you remember to get rid of a root with 2 power. Last step, divide by 64, right? Divide by 64, you're going to get 256? Yeah, 256. H is 256 feet high. Must have dropped that object from 256 feet out. I mean, officially, yeah, but it's right. Yeah, I can tell you it's right. All right.